Welcome to our lesson on Rhombii or the rhombus. So today's objective is we will know the properties of a rhombus and we can use them to find the length of a side or diagonal, the measures of angles, and to solve for a variable. So the rhombus is a parallelogram with four congruent sides. Because it's a parallelogram, it holds the same properties as a parallelogram. In other words, opposite sides are parallel, opposite sides are congruent. Even though all four sides are congruent, we can still say opposite sides are congruent. Opposite angles are still congruent. So the red angles are congruent and the gray angles are congruent. Consecutive angles are supplementary. So remember, this meant that we could draw a set of parallel lines in here and use the other side as a transversal, and we would have red and gray angles being our consecutive interior angles, which means that they are supplementary. Our diagonals will still bisect, or in other words, cut one another right in half. So those are properties of a parallelogram, but a rhombus, because it has four congruent sides, has a few other special properties. So the diagonals are perpendicular. So the angles inside the middle there where those diagonals intersect, those will all be 90 degrees. And the diagonals bisect the opposite angles. So since opposite angles are congruent, it doesn't matter their measure. If I cut them in half, each of those halves are going to be congruent. So in our diagram here, we can see we have four smaller green angles that are congruent and four smaller yellow angles that are congruent, because that larger angle is being cut in half, making those smaller congruent angles. And by definition, the rhombus has all sides congruent. All right, so this first one is just a quick practice on rapid practice using segment lengths. So hit pause and find these four lengths of the segments listed here on the right. Don't miss out that MT equals 16. All right, go ahead, do those four problems. Okay, let's go over these. So the segment ST. ST is going to be 17 because it is opposite of MR. The segment RT is this right side over here. RT is also 17, and that is because this is a rhombus, and a rhombus has four congruent sides. So all four of these sides are congruent or the same length. MP. MP doesn't look like it has any information on it, but it tells me that MT is 16. So if MT goes all the way across, since the diagonals bisect, to go halfway across would be 8. So MP would be 8. And finally, find RP. So RP is half the diagonal. So if SP, the other half, is 15, RP must also be 15 because it's bisected or cut perfectly in the middle. All right, so that's just a little bit about segments and reviewing properties from parallelograms. Let's look at the angles of a rhombus. So if this rhombus, HOME, and it has the diagonals here where it intersects at S, we want to find all of the missing angles. The first thing I'm going to do is fill in these middle angles at 90 degrees. And that is because the diagonals of a rhombus are perpendicular. So those will always be 90 degrees. Next thing I'm going to go ahead and do is I am going to take this 26 and I am going to put it on the other side as well. Because remember that the diagonals bisect the angles. So remember a couple slides back where we had those 4 green triangles and the 4 yellow triangles? These are going to be congruent on each side because they bisect. And speaking of that, remember those green triangles and the orange triangles or the yellow triangles? They were directly across from one another. So 26 degrees, because it's up here, I can also put it down here, and we could say that those were alternate interior angles. But that means that this is also 26. One, alternate interior angles with the top left one. Or we could look at this again as being the bisecting angle. So if that left side is 26, my right side must also be 26. Now we need to find these smaller angles here. To find those 4 smaller angles, we are going to use triangle sum theorem. So if I were to look at this upper right corner of the rhombus, that triangle there, we know that all the angles of a triangle add up to equal 180. So 26 plus 90 plus x equals 180 degrees. Combine my like terms. So 26 plus 90 is 116 plus x equals 180. Subtract 116. So x equals 64 degrees. So this angle is 64. And we're going to repeat that whole process with our bisecting angles. So if this top one is 64, the bottom is also 64 because the whole angle H is being bisected or cut perfectly in half. And then that's also going to come over here to M and be 64 degrees. So those are just how we would go about finding the angles of a rhombus when we have all the diagonals drawn in there. Let's do a few examples where we're going to be solving for our variables. So this is a rhombus and we want to solve for r. When I look at these 2 angles, I notice that these are consecutive angles. So with consecutive angles, remember, those are supplementary. So I'm going to write consecutive angles are supplementary. And then I'm going to write that out algebraically. So supplementary angles means I can add them and equal 180. So 5r plus 2r minus 9 equals 180 degrees. Solve for r by combining like terms. So 7r minus 9 equals 180. Add 9 to each side. 7r equals 189. And then divide by 7. So r equals 27. Again, that's because our consecutive angles are going to be supplementary, so we can add those up to equal 180. Here's a different type of problem. This is a rhombus, but notice only one diagonal is drawn in, and we want to solve for k. Let's think this problem out just a little bit here. A rhombus has 4 congruent sides. So this is congruent and this is congruent, as well as these other 2 sides. If those sides are congruent, let's look just at this top triangle here on the left. So that yellow triangle that's highlighted, this is an isosceles triangle because it has 2 congruent sides. So those congruent sides are those are my congruent legs, which means that this is going to be my base. If that's my base, then I have these two congruent base angles. So now, with those congruent base angles, I can see that congruent means equal. I've marked them congruent. Algebraically speaking, we're going to be dealing with equals. Now we can solve for k. So I move the k over, and then I'm going to add 12 to each side, and finally divide by 2. So 10 equals k. And again, this is because we could make an isosceles triangle here to show that we had base angles that are going to be congruent. You could also think of this problem as back at the beginning where we had those 4 green triangles and the 4 yellow triangles showing those congruent angles. So my green triangles would have been here and here, as well as these 2 angles up here. And that would be a reasoning you could go through to show that the angles are also equal or congruent. Okay, here's another problem. Solve for W if the measure of TPR equals 18 minus 6W. So TPR, let's trace the angle. T, P, R. That's the angle right here. And we want to find what measure W is. So this angle is in the middle of my rhombus. Remember that a rhombus, the diagonals are perpendicular, which means that they're going to equal 90 degrees. So to solve for W, all we need to do is set this equal to 90 degrees. And that's because diagonals are perpendicular. And you can use that perpendicular symbol, the upside down T. So I'll go ahead and subtract 18 from each side. So 72 equals negative 6W. Divide by negative 6. So negative 12 equals W. But you have to remember on a rhombus, you have that 90-degree angle all in the middle there, okay? All right, here are 2 examples here. All I want you to do is set it up. So I'm going to give you guys a moment to set up the equations. You don't need to solve them, just set them up. Okay, so let's talk about setting this up. I'm going to solve for x first, just because it comes first in the alphabet. So 3x plus 4 is talking about the top side, and 2x plus 12 is talking about the right side. So on a rhombus, all of the sides are congruent, so I can say 3x plus 4 equals 2x plus 12. And that's because it has 4 congruent sides. The other part of this problem is solving for y, but we just need to set it up, remember. Okay. So to set this up to solve for y is talking about the left side of that diagonal, and 15 is talking about the right side. So my diagonals still bisect, which means this left side is congruent to the right side. So y minus 7 equals 15, and that's the reasoning of diagonals bisect. Okay. So on our last problem, we had diagonals were perpendicular because we were talking about an angle. This is talking about the segment of the diagonal, so now we're going to use the reasoning diagonals bisect because that's the segment. And you could go ahead and you could solve this if you chose to, but we're not going to do that in this lesson. Okay? All right, last problem. Okay, this is like a rapid practice problem. Everything is in there that you need. And it may be helpful for you to imagine that this diagonal comes all the way across to that angle. Alright, go ahead, pause the video, and find the measure of each of these angles here. Okay, so first thing is, it's really important to remember that there are lots of ways to do this problem. So how I do it here may not be the same way you do it, but there are certainly multiple ways that you could solve this and do it correctly. I'm going to start with this triangle that's on the bottom half. And remember that this is an isosceles triangle, which means A and B are going to be congruent. So this would be X and X. So I can use triangle sum theorem. X plus 110 equals 180. So subtract 110 and combine my like terms. 2x equals 70. And I'll divide by 2 to find that x equals 35. So I'll go ahead and put that in here. I will also remind myself that on a rhombus, the diagonals bisect the angles. So if one side of that angle is 35, then the other side must also be 35 for it to be bisected. That center angle, remember, needs to be 90 because our diagonals are perpendicular. It even marks it in there with that box. So E must be 90 degrees. And then finally, to find F and G, you could do a few different things based on what we have. We could use the triangle sum theorem to find F. We could also take 110 degrees and divide it in half. Okay, just like I have that dashed in diagonal there, dividing that 110 in half. So we could do 110 divided by 2 equals 55. Or if you want to use triangle sum theorem, F plus 90 plus 35 equals 180. And then solve from there. Either way, you end up with F equals 55 degrees, which means G is also 55 because that angle is bisected, so each side has to be congruent. Okay, so let's look at a few things to remember. Remember that a rhombus is a parallelogram, so all of our parallelogram properties are still true on a rhombus, and the only new things or new properties about a rhombus we need to remember is that we have perpendicular diagonals. That means that our angle in the middle where those diagonals intersect is 90 degrees. Our diagonals bisect the opposite angles, okay? Those 4 green little triangles and those 4 yellow little triangles from the beginning. And also, a rhombus has 4 congruent sides, okay? So those are the only new things. We're just adding 3 simple little things to the parallelogram properties we already know. And that's it for this lesson.